equation, we don't have to have a calculator, but we should know how to solve. All right, so if I'm going to solve that equation, Alyssa, what would I do to solve that equation? Perfect. I would subtract that 30. So I got negative 30 equals negative 16t squared. What would I do after that? Not yet. Let's divide by that negative 16. And so if I do negative 30 divided by negative 16, I will get 1.875. Okay, and then what would I do after that? Square root. So if I square root that, oh, sorry, I thought it was Desmos. There. We get 1.369. Which is our time that we got over here, right? So if it's calculator active, certainly use the calculator, but you might see something like this on calculator inactive. Okay, questions? All right, let's do another example. All right, soccer ball is kicked with an initial upward velocity of 20 feet per second. How long does it take for it to hit the ground? So let's think of that equation that we had on the last slide. It's h equals h sub 0 plus v sub 0 t minus 16 t squared. So really what you have to do to get your equation is you got to plug something in for your h sub 0 and something in for your v sub 0. Okay? H sub 0 is initial height. That's how high the object is to start with. And then v sub 0 is initial upward velocity. If something's dropped, its initial upward velocity is 0. Otherwise, they're going to probably tell you what the initial upward velocity is. In this case, what did they tell us it was? 20. All right, so we will put a 20 right here. What is my initial height? Okay, so, and a lot of times it will say it is kicked from the ground. It did not say that here, but we would assume that if the soccer ball is kicked, that it's kicked from the ground. I guess if it's like a goalie has it and is punting it, maybe not, but we're going to assume from the ground. It's from the ground. And so if we're kicking something from the ground, its initial height is 0. So we want to know how long it takes for this to hit the ground. So we're just going to go over to our Desmos. I want everybody to type theirs in as well. Okay, so type that into Desmos for me. And we're looking again for where this hits the ground. So let's see, Jada, where is it going to hit the ground? Or how long? 1.25. Okay, that looks good. Let me see. I'll use the R for the last letter. They should both be T. Yeah, they're both T. Alright, anybody else have any trouble? We're not going to grab. Hey, any trouble? Okay. Alright. Alright, so a pumpkin is launched from a height of 25 feet with an initial upward velocity of 80 feet per second. How long until the pumpkin hits the ground? So this is what we'll be doing, although we won't be launching our pumpkin from 25 feet. And we're going to have to find our initial upward velocity. We've got h sub 0 plus v sub 0 t minus 16 t squared. We need to find the h sub 0 and the v sub 0. So, let's see, Zane, tell me what the equation is going to look like here. Okay, we're looking for our initial height first. So what height does the pumpkin launch from? Good. So 25 would go right there. And then, what is the initial upward velocity? That v sub 0 is our initial upward velocity. 80. So we'll put 80 right here. Make sure you don't forget the t right there. The biggest thing students do wrong is they forget to put the t beside the 80. And then we'll have minus 16t squared. That's your acceleration due to gravity. It's always the same. So 25 plus 80t minus 16t squared. Oh, I can't see anything. What's happened here? Too big. I'm going to go over here to my wrench. What do you guys think I should try for my y? Somebody give me a guess. What do you want to try, Julian? How high do you think I should make this? It's at 35 right now. Didn't change much. Okay, Marla says 90. It's better, but not there. Let's take. That's pretty good. But now I need to sort of drag it over so I can see the whole thing. So, whenever it's not showing up well, try to get your window correct. All right, we need to know how long till this pumpkin hits the ground. So, I want everybody to make sure they've got this in their Desmos and has a graph that they can see. Okay, I could call on anybody here. So make sure you have it in. Okay, Zane, what are you getting?
I got
5 point what? 5.295. Let's see if that's what I've got. That is correct. So my time equals 5. Ayla, don't do things. 5.295, and this would be seconds, because this equation always is going to have seconds as your x. Okay, questions? Okay. 4, a penny is thrown off of a 120-foot tall building with an initial upward velocity of 25 feet per second. How long does it take to hit the ground? So, Passion, I'm going to have you help me with this one. We've got h equals h sub 0 plus v sub 0 t minus 16 t squared. We need to replace our h sub 0, which is our initial height, and our v sub 0, which is our initial upward velocity. So what is that going to be? What's our initial height going to be, Passion? Give me the equation first so I know what to plug into Desmos. So what is our initial height? 120. And then what is initial upward velocity? 25. And then we'll have t minus 16 t squared. All right, so this is what we're going to type into Desmos. everybody type it in. My window looks pretty good here already. I'm not going to change much. Question, Wade? Or you just got it already? I'm going to see what Passion gets for this one. Your window's just bad. Go over here to the range. Go down here to this Y. Yeah, I know the building was 120 feet tall, so I changed it to 120. It's going to be at least that. Then you might be still zoom out a little bit. Yeah. Yeah, there you go. Now you can see. So where's that going to hit the ground? Ground will be right here. Exactly. 3.629. Is that what you got, Wade? Yep. All right. So T is going to equal 3.629 seconds. Okay. Any questions so far? I love these problems. I think they're, especially with Desmos, I think it makes it not too terribly difficult and kind of useful here. So, you know, if somebody throws his penny off of this skyscraper and you're standing beneath it, you have 3.6 seconds to move before it hits you in the head. It's going to probably cause some damage from that height. There. I know it, when my husband was at NC State that first year, his building had he was on the 7th floor, but I think it had 12 floors maybe, and there were often people who liked to throw water balloons from that top floor because they had balconies out there where you could. Yeah, I feel like it would. Yeah, so you could make some calculations there. All right, so this is a different question. So all four of those first ones were asking us for when we hit the ground, right? So when you're looking for when you hit the ground, you're looking for that x-intercept. But this one says the softball is thrown from an initial height of 5 feet with an initial upward velocity of 40 feet per second. What is the maximum height the ball reaches? So this is not asking for the same part of our graph, right? This one's going to ask for that maximum point, which is going to be up here, which we haven't changed the equation yet, so we need to do that. Laura, what's the equation going to look like for this situation? Mm-hmm. What? Okay, so the original formula that's the same every time, right, looks like this. So that very first formula that you had, it's the same every time. So H sub 0 and V sub 0 have to be replaced. So in this case, what is our initial height, that H sub 0? 5 feet. So 5 goes right there. What is our V sub 0, our initial upward velocity? 40. Good. And then the rest of it's always just the same. T minus 16 T squared. So that is our equation. H equals 5 plus 40T minus 16T squared. And so we will type that in. And so if they ask us how long it would take to hit the ground, it'd be 2.619. But that's not what it asked us. It asked us the maximum height. So I've got 1.2, comma 30. So the maximum point if I write down both of those, it's 1. What was it again? 1.25 and then 30. But that's, I can't give two answers, right? Only one of those is my answers. Which one is the answer? It's the 30, right here. This is your height. Because if you think about your equation, your height is in that y spot right there. If it asked you for time, it would be this number. So if it said, what is the time when it reaches its maximum height, you would give 1.25. But 30 feet will be our answer.
So is the height always going to be the y?
Yes, height will always be your y coordinate. It wasn't too hard to figure out when we were asking when it hits the ground, because only one of the numbers was the logical answer, right? We knew 0 wasn't going to be the answer, but it's easy to get it mixed up a little bit here. All right. A toy rocket is launched from the ground with an initial upward velocity of 90 feet per second. It lands on top of the house, which is 20 feet. How long did it take to land on the house? So this one's a little bit different here too, because is this rocket hitting the ground? No, it hits the roof of the house, right? But it doesn't affect our equation. So h sub 0 plus v sub 0 t minus 16 t squared. So initial height. Vince, what is the initial height? Okay. It's not 20. That's where it lands. That's where it ends up. Initial means at the beginning. It's not 90. It's 0. Why? It's on the ground. You're launching it from the ground. So that's 0. The v sub 0, that's initial upward velocity. So initial upward velocity is 90. And then the rest of the equation stays the same. So we would go over here and type in our equation. You can leave out that 0 if you want. So I can tell when it hits the ground, but I don't want to know when it hits the ground. I want to know when it hits 20. If I try to move my point here, I can get pretty close. So right there was really good. 20.019, but it's not quite 20, right? Does anybody have an idea of how I can get it to be exactly 20? Since we're using h and t, say h equals 20. Shoot. Maybe y equals 20. I don't know if it's going to do it right. Yeah, it does. Okay, do y equals 20. It won't let you do h. It's not recognizing that. So, but h is your y coordinate here, right? So, if I do y equals 20, now it has a gray dot right there where they cross. So, I can see that it hits the house at 5.393 seconds. So if it's not hitting the ground, it's hitting something else, it's not going all the way back down, then you can just put in a line there at that point. Excuse me. Okay, questions? All right, so just to recap a little bit, hit the ground, you need to be looking for the 0, the x-intercept of the graph. I don't know if I've used that word very much there, 0. But that word 0 just means x-intercept. So that needs to be a vocabulary word that you are also aware of there. Maximum height, of course, we just look for the maximum of the graph. When will the height be whatever, like 20 right here? We're going to find the intersection of the point. So in this case, it was like y equals 20. And that initial upward velocity, we're going to have to do that by hand, but we're not going to do that today. We'll look at it tomorrow, which I think this next question is doing that. Okay, so we're not going to do this problem today because we don't have time to do it properly. We're going to let you start on your assignment and maybe get one of them done. But this is what we're going to do with our pumpkins because initial upward velocity is hard to find. So we'll finish 7 tomorrow. So your assignment for tonight, one of them's going to go away, is, and don't put your computers away, I want you to go ahead and start on the first one. All right, so there are 3 quizzes here, okay? When I say quizzes, they are set up as a quiz in Canvas. They are actually going to go in your quiz section, so your grades do matter. I think the third one is the one I need to move to tomorrow. Let me look at it really quickly. Yes, please do on all of them. Yeah. So the third one, I'm going to move it till tomorrow because we need to go through those. I think we should be able to do 1 and 2. I think 1 is mostly going to ask you about when something hits the ground, and 2 is going to ask you about maximum heights. Please use Desmos to do all of these, okay? So you shouldn't be like solving all this by hand. You should be typing it into write your equation, type it into Desmos, get your answer. Yes. Yes. I got an email about that. Go ahead. Okay. Now, every single problem you're going to get is going to start with the same information. That is just giving you the formula every time. Because if you see these on the actual test, they'll probably give you the formula. And so, actually, I clicked on the first one. These might be, all the first ones are maximum height. Or they ask you like initial height there. So you will do both of these. It will show you which ones you missed, so you can go back and try again on those. And it should be unlimited. So this is your homework. Go ahead and start the first one. It'll save where you're at. So even if you only get a couple questions, then you should have time to do that.